Math 3, Unit 9, Section 4. Today we're going to be talking about graphing logarithmic functions. Now, throughout this unit, logs and what have gone together?
Numbers.
Very good. Numbers is part of it. But we can change log equations into what other equations? Exponential. Now, we have done exponential graphs this entire year. Okay, since Unit 1. All right? So that means that we should have some type of thought process and idea of what this might look like. What do exponential functions, do you guys remember? What type of graphs did those look like?
This one, right?
Yeah, very good. It looks something like this. So if this was my coordinate plane here, it like shot up like that, right? Do you guys remember which point all exponential functions had, and then we would like shift it? Very good. There was this point right here at 0, 1. Okay, this right here is exponential. Okay. So these are going to relate. All right. The first thing we're going to go ahead and do is let's just remember how we talked about this last week, where if we get to a problem, they're asking us to graph it, and we have no idea what to do, we should start plugging in points to see what happens. Okay, so we're going to plug in points to see what happens and see if it can give us some information. So if I plug in 1 here, that means it's saying log base 2 of 1. I'm plugging in 1 for x into this equation. Okay, now 2 to what power equals 1? 0, right? Okay, so now if we plug in 2, we have log base 2 of 2. 2 to what power equals 2? 1. Is everybody okay with what we're doing? Okay, then we plug in 4. Log base 2 of 4. So that's saying 2 to what power equals 4? 2. Log base 2 of 8. 2 to what power equals 8? 3. What will be log base 2 of a half? 2 to what power makes a half? It's actually gonna be -1, right? Because we want to bring the 2 up so it's not a fraction anymore, and in order to do that, it would be a -1. And if you want to see this, you remember how we can always go equals x, and then this is saying 2 to the x equals 1/2. Let me just put this up here for a second. And so then in order to get rid of that 1/2, we know that 2 is to the first, so to bring it up, we end up getting 2 to the -1, which is why that value is -1. So that means on this one, when we have log base 2 of 1/4, that answer will be what? Very good. And then the last one, log base 2 of 1/8, will end up being -3. Okay. So far, so good? What should I do with all those values? Plot them. Very good. Put them on our coordinate plane. So our first point is 1, 0. So we're going to go right 1, up 0, make a point. Then we have 2, 1. We have 4, 2. And then we have 8, 3. Okay, then it goes 1/2. So we know 1/2 is in between 0 and 1, so 1/2, -1. 1/4 is getting closer to 0, right? So 1/4 is at -2, and then it says 1/8 is at -3. Will it ever touch 0? Could x ever equal 0? Can you have a 0 in that spot? No. And so because x can never be 0, there is what on this line right here? An asymptote. Very good. And so I'm just going to draw that asymptote in there. And so that means that this graph is getting closer and closer to the 0, and then it's going to curve going up that direction. So what is different or similar to my log function and my exponential function? On my exponential function, we had an asymptote here. And remember how it got closer and closer to the x-axis and then shot up that direction. So, similarities. What's a similarity, Katie?
They have the same shape.
They have the same shape. Well done. What other similarities? They both have asymptotes. Good. So they both get close to a line of 0. Just one happens to be the x equals 0. One happens to be the y equals 0. So on this graph right here, let's go ahead and answer these questions. What is my x-intercept for our graph? So the x-intercept is at 1, 0. Okay? The y-intercept, does it ever touch that y-axis? No. No, so that's none. Does that make sense? Okay? Domain, going from the left to the right, where does it start? Very good. So, and it's going to be a parenthesis because it can't actually equal 0, but it's getting close to 0, right? So it starts at 0 for the domain, and it's going to go to what? Positive infinity. Very good. Now the range, there's an arrow down here, which means it's going to start at negative infinity, and it goes all the way up to positive infinity. And there is a vertical asymptote, which is at what? X equals 0. So if you change this to an exponential function, normally you see your log functions look like this. Log base 2 of x, it would be equals y. The equals y would be on the other side. And how would you change that to exponential? It would be, your base would be what? 2. The exponent would be y equals x. Okay? Now, this exponential function, this equation is actually something like this. It's a y equals equation, and it was y equals 2 to the x power. Okay? So this is, I'm talking about this piece right here right now. So when we were solving this one and we did a t-chart, x, y, when we plugged in, we were plugging in values for x. So I plugged in 0 and I got 1. And I plugged in 1 and I got 2. And if I plugged in 3 for x, I got 8. If I plugged in -1, what would I get? What happens when you have -1 in here? Very good, 1/2. You have to move it down and it becomes a fraction. If I plugged in -2, I would get 1/4. Very good. Now, I want you to look at these two charts. And what do you notice about them? They are similar. Yeah. X and Y is flipped. Do you guys see that? So here x is 1, y is 0. Here x is 0, y is 1. Here x is 2, y is 1. Here x is 1 and y is 2. Now, if you look at these equations, what do you notice about x and y? They're also flipped. Okay, when this happens, this is called, just so you know, an inverse function. So an inverse function is when you are exchanging your x and y values. Okay. Yes?
So, question, if you put both an exponential function and a logarithmic function on a graph, would it look like a, I forgot which kind of function it was earlier. It's 2 lines, it's 2 separate lines that never touch, so they look like that.
Kind of, except for it would be difficult to put these both on the same graph because this one has an asymptote here and it's touching the x, where our other exponential function has an asymptote at y equals 0, and so they wouldn't actually work to be on the same graph. But if you just were wanting to overlay them, it would kind of look like that. But yes. Okay. And so that's just like a little piece of information. Okay, we're going to talk about inverse functions again later. The main idea here, though, is just like our exponential functions always had a point at 0, 1, our logarithmic functions all have a point, like a starting point at 1, 0. Okay, and then we might have to translate them based on that. Okay, so going to this next example, and these will take a little bit less time. That was just to give you some background knowledge. What do you think this is going to mean right here? Down 2. So remember, when we're going left and right, it's usually with x in parentheses, correct? And this right here is not in parentheses. And so this right here just means that you would go down 2. Okay, so we know that we should have an asymptote always at, so the couple things that we know is that we're going to have a point at 1, 0 to start with. And then you have an asymptote at x equals 0. Okay, so this is kind of like your starting points. But if we translate, these things can move, correct? Yes? Okay, so if we have a line at an asymptote at here at x equals 0, and you translate down 2, is that going to change the asymptote at all? No. So we can go ahead and draw that in. We know there's going to be an asymptote there. Okay? And then normally we would do something where at 1, 0 we put an x, and then we translate that. So that means that that's going to actually translate which way? Down 2. So it's no longer going to be here, but we're going to move it down 2, and so that means my asymptote is actually going to be here at 1, negative 2. Do we have questions on any of that?
Wait, why did you change the asymptote?
I didn't change the asymptote because if you were to take this line and just move it down 2, it's going to still stay at x equals 0. The only time the asymptote will move is if we're going to be translating right or left. Okay? Now, we have an idea what this graph looks like because all logarithmic functions look like this. Okay? But I don't know exactly where it's going to cross the x-axis. Does anybody have any idea on how we could figure out the x-intercept? We can plug in numbers. Good. Plug in 0 for what?
1.
Very good. So remember that anytime you're finding your x-intercepts, we plug in 0 for y and solve for x. Do you guys remember that? Something else we've been doing this whole year. So I would write this as 0 equals log base 3 of x, I don't know what that was, minus 2. And what would I do? How would I get the log by itself? Let's start by adding 2 to both sides. Well done. I also would rewrite this right now. I'm going to write this as log base 3 of x equals 2. I'm just going to flip my equation. What would you do at this point? Wrong answer. Thank you, Isaiah. What would you do?
Well, first I would make it equal to y.
Actually, you don't need to do that. So we're just trying to solve for x right now because we already know that y is 0 because we plugged in 0 for y. I'm trying to find the x value. Trini, what would you do?
So we happen to divide by log 3.
Nope. Can we change this into another form, Tracy?
Is it 3 to 5 equals x?
Very good. change it to exponential form. 3 to the second power equals x. Can you guys solve that? Yes. It's what? 9. Was that really that difficult? So remember what we talked about earlier today is how log and exponential functions go back and forth, right? And so we have a log function. Well, if this makes no sense to you, change it to exponential form and see if it makes sense. Yes?
Is this just a 9 0 because you just solved for x?
Yes, thank you.
Filled in 0.
Well, wait, no, 9 0, thank you. We plugged in 0 for y and solved for x. Thank you. Candy for you. Okay. Are we okay with this? So 9 0, this line right here is 8. So 9 0 is like 1 off here. So this would be 9 0. And then we know it's going to get closer and closer to our asymptote, going that way. And then this way we're just going to curve and touch our x-intercept, and we know it's going to keep going up that direction. So now we should be able to answer all these questions. What is my x-intercept? We just found it. Okay? 9 0. Will this graph ever touch the y-axis? No. So the y-intercept is none. My domain is what? Where does parentheses 0, and it goes to positive infinity. My range, well done, negative infinity to positive infinity. And my vertical asymptote is at, well done, x equals 0. Okay, yes?
So basically, nothing changed except for the x-intercept?
Very good. But it depends on your shifting, okay? So yeah. All right, so we're gonna do a couple more examples so we can see what other problems look like. Okay, this one, where will this one translate? Right to, very good. So I'm gonna make a note to myself that this means it's gonna translate right to. What's wrong?
She asked me if she was, yeah.
Oh, sorry. Okay. So we know that we are going to have the point at 1 0, and our asymptote is going to be at x equals 0. Okay? So normally this asymptote is at x equals 0, but we are translating right to. So is the asymptote going to move? Yes. So from 0, it's going to go right to 1, 2, and so now I'm going to draw this asymptote at this line, going right to. Normally we have this point, which I'm going to do a little x there, at 1, 0, but we are going to move it right to 1, 2, and there is that point. What do you notice about this? Everything did go right to. I notice here, because I didn't go up and down, do I already have my x-intercept? Yes. Now, could we find another point? We could. We could easily find another point by like plugging in something here. I would suggest that you always find at least one more point to make sure it's slightly accurate. So if I am dealing with base 5 here, what would be a great value to plug in here to make it work out nice? Well, if you plug in 5 here, you get 5 minus 2, which is 3. So what could I put in here in order to make it 5? 7 would be the correct answer. 7 minus 2 is 5. Do you guys agree with that? Okay, so if I'm plugging in the x value of 7, that means that this problem is log base 5 of 7 minus 2. 7 minus 2 is 5, log base 5 of 5, and we know 5 to what power equals 5? 1. And so another ordered pair that we could put on this graph would be 7, 1. So right here. So we know this is going to get closer and closer to the x-axis, and then this is going to curve this way. And now we can answer all of this information. What is my x-intercept? What value is that at?
3, 0.
Very good. 3, 0. My y-intercept? None. It will never touch the y-axis. This one, what's my domain going to be on this one? Where is it starting at? Very good. Parenthesis 2 to positive infinity. What's my range on this one? Negative infinity to positive infinity. And what is my vertical asymptote? Well done. Okay, do we have questions before we move on to this next one? Okay, what do you notice about this next one? Natural log. Okay, these graphs will still look the same as a log graph. Okay? But there's something else there that's a little bit scary. The negative. What does that mean? What does that negative mean? Okay? So it means that it reflects over which axis? X-axis. Okay? So when it's reflecting over the x-axis, in terms of our starting points, they are on the x-axis already. And so those are not going to flip at all. Okay, but the curves will. So if you're looking at here, if this was reflecting over the x-axis, instead of this part curving down, this would end up curving up. And then this part would flip over here and it would be going down. To visually show you, just real quick, so this isn't actually part of this graph, but if this was reflected over, so that part would be like that. Do you guys see how those are like symmetrical and flipped, like a mirror image? And then same thing would happen here. This point would go down here and it would look something like that. If it had that negative in front, it would look like that, blue line-ish, okay? So we have a reflect over the x-axis, and then we also have this +1 here, which means what? Left 1. Is everybody good with that? Okay, so let's start with just our translating and not our reflection yet. And so we have this point at 0, 1, and we have like our asymptote that will be here at x equals 0. So I'm going to write that. We have our 1, 0 point, and we have our asymptote at x equals 0, and then we want to translate. Okay? So what's going to happen with the asymptote? Very good. It's going to go left 1. So we go from 0, we go left 1, and so we draw that asymptote in right there. Okay, what's going to happen with this little x here? Left 1. Okay, and so my point is going to be right there. What is really nice about where that point showed up? It's at 0. So that means on this one, what is my x-intercept? 0, 0. Does this one have a y-intercept? Yes. What's the y-intercept at? 0, 0. Okay, nice. So normally, if it wasn't reflected, this would start curving down here. Do you guys agree? But because of the reflection, it's going to be up. So it would start curving like this. Now, we know that it's always a good idea to usually get another point somehow. We already have, I don't know. We're just going to not do another point right now because I don't want to confuse you guys more. Okay, so we're just going to deal with the reflection, and then this one would do what? Keep curving like that. What's my domain? -1 to positive infinity. What's my range? -infinity to positive infinity. And my vertical asymptote is at x equals -1. Okay, any questions? All right, last one. I try to give you something that looks like everything on your homework. This one, the way that they have written this equation, to me, makes it confusing. Okay? So I would rewrite this. You always want the log part first and your translating part second. And so what I'm going to do is rewrite this, but put the +3 at the end, and then the negative log part is in the front. So what I mean is y equals negative log base 2 of x plus 2. And then that 3 is a positive 3, so it's plus 3 at the end. So there is a lot of stuff going on in this. First of all, there is a negative in front of the log, which means that it's going to do what? Very good. It's like you guys listen to me. Okay, I heard that. Okay, this next part right here, what does that mean? Well done. It's like you can even read my mind now. Okay, left 2, and then we have up 3. Okay. The next thing is we should always start with our starting points. Good. And what are those starting points? 1, 0, and very good, asymptote at x equals 0. So we're just going to kind of lightly draw these here for a second, and then we're going to translate. Can we do 2 translations at one time?
Yes.
Okay, so we're going to deal with these translations, right? Our up 3 and our left 2. So with our asymptote first, if we go up and down 3, it's not going to change the asymptote, correct? And so then we're just going to go left 2. So we're going to take this, left 2, and here is my asymptote. Okay? At our point here at 1, 0, we are going to go left 2, up 3, 1, 2, 3. And you could have also gone up 3 and then left 2, right? You'd still end up at that same point. What I don't like about this right now is that it's not touching my y-axis and it's also not touching my x-axis, which means I have to find both of those intercepts, which takes more work and is annoying. Okay? But that's just the way it is. We also know that this is a reflection, so we do know that it's going to be curving and getting close this direction, right? And then it's going to curve down this way. Now, if we find our x and y intercepts, we'll see the points, and it will be very obvious how it's going to curve as well. So we need to find both the x and y intercepts. Are you guys ready?
Sure.
Okay. X-intercept is actually the most difficult on this one, so we'll start with the most difficult. Okay, x-intercept. Here we go. How do I find the x-intercept?
Plug in
0 for y, solve for x. Okay, so if I write this out, you could plug it into either equation, but I'm going to go with this one I wrote right here. So I have 0 equals negative log base 2 of x plus 2 plus 3. What will you do next? Good. Subtract 3. Okay, now remember the log is basically like this is stuck together. Okay, so now I have negative 3 equals negative log base 2 of x plus 2. Okay, the negative in front, you can divide by the negative. Okay, so I'm going to divide by negative 1 to both sides. These cancel. And I'm going to flip this around, like the equation. So I'm going to write this now as log base 2 of x plus 2 equals what?
3.
Positive 3. Okay, now because that is in parentheses here and this is stuck with the log, I can't do anything else with this log. But what can I do? No. Isaiah.
4.
What?
Add 4.
No.
2 to the third.
The only way to get rid of this log is to change it to a different form that doesn't have a log. What form is that? Yeah, exponential form. So 2 to the third equals x plus 2. What is 2 to the third power? 2 to the third power is 8. And then we have x plus equals x plus 2. And then can I finish solving this? I hope so. Okay, and so we get 6 equals x. Okay, this is the point where a lot of you are getting stuck. So you need to remind yourself that at this point, change to exponential equation. And that is not great English. Change to an exponential equation. Okay. So x equals 6. My x-intercept is at 6. So I'm going to go right 6. 1, 2, 3, 4, 5, 6. There is the x-intercept. Okay. I also need the y-intercept. What will I do in order to find the y-intercept?
Plug in the square to solve for y.
Very good. So I'm just going to label this right here. Y-intercept. Okay. Using my equation again, I am going to keep y. So we have y equals negative log base 2 of 0 plus 2 and then plus 3. Okay, so what is 0 plus 2? 2. So this is negative log base 2 of 2, and then you have plus 3. Remember that this whole thing with the log, that's stuck together. So you can't go 2 plus 3 and get 1. That is incorrect. Okay? But do we know 2 to what power equals 2?
It's
1. And because there's a negative in front, it's a negative 1 plus 3, which equals 2. So my y-intercept is at 2. So right here, we'll go ahead and make our point here at 2. And then we can accurately graph and fill in our information. So what's my x-intercept? What's my y-intercept?
0, 2.
What's my domain?
Negative 2 to positive infinity.
Negative 2 to infinity. My range will still be
Negative infinity.
negative infinity to positive infinity. And my vertical asymptote is at x equals,
Negative 2.
well done.